Hello, everybody. My name is Gilad Golan. I'm Engineering Director for Security and Trust in G Suite. And with me today is Nico.
Hi, I'm Nico Lizborski. I'm Engineering Lead for Security and Trust on G Suite.
And today we'd like to talk about email security. So, email, we love it, we hate it, it clogs our inboxes, it follows us around on our phones, but we can't pass a day without it. Email has become the lifeblood of any organization. So by the latest estimates, there are 3.7 billion email users, and every day there are around 269 billion email messages sent and received. And what made email so powerful? So email is universal, it's open, it's fast, and it's free. So think about it. It's universal, open, fast, and free. That's what makes email so powerful, but it's also what makes it the most popular attack vector for cyber attacks, which is why we want to spend this talk today discussing email security. So today, what we're going to talk about, we'll discuss some of the latest threats that we've been observing related to email security, and we'll tell you what Google does to protect you against those threats. And then we'll finish by walking you through some of the things that you, as admin, should do to take advantage of the protections that we provide. So these are the main email-related threat categories that we discussed today. So we're going to talk about spam, phishing, malware, impersonation, and interception. And we're also going to discuss email client security and data loss prevention as it relates to email. And we're going to start with spam, which is the most common one. So spam is unsolicited, irrelevant, or inappropriate messages sent over the internet to a large number of recipients. And we all know it, we all get it, we almost become used to it. It's mostly commercial advertising. It's often for dubious products, all sorts of get-rich-quick schemes. The damage for organization, it's mostly waste of time and productivity loss, but it does add up. So over time, it can be significant. So what does Google do to protect you against spam? And to understand what Google does, we need to take a step back and look at the progress of machine learning in Google across all Google products and services. So today, usage of machine learning in all of Google products has grown exponentially. And specifically, the latest developments in deep learning enable powerful new capabilities not possible before that. What you see in this graph is the number of deep learning projects across all of Google products. So you can see the huge growth over the last couple of years. And the progress and the shared infrastructure that we built that powers these innovations across all of Google they enable us, they give us capability that seemed impossible only a few years ago. Just to give you an example from a familiar product of the kind of magic that deep learning provides. So this is how Google Photos uses deep learning models to analyze photos and to auto-tag them. So using machine learning and deep learning, Google Photos can analyze the photos like the one you see on the left and determine that this photo should be tagged by the tag ocean. So let's get back to spam now. We take the similar kind of magic that you see in photo tagging and apply it to spam detection. So in Google, for spam detection, we use what data scientists call Ensemble. Ensemble is when you take a number of machine learning models and you use them and combined to achieve higher accuracy. So what you see in this diagram is the different models that we use and the kind of spam detection accuracy we achieve with that. So when you use them in combination, we achieve 99.9% accuracy. And we keep improving it. So what does it mean? That means that we have less than 0.1% false negatives. This is spam not detecting, ending up in your inboxes. And we have less than 0.05% false positive. This is mail by mistake labeled as spam and not showing in your inbox. By the way, the imbalance that you see between the two is by design, because false positives are much more disruptive to business than false negatives. So our models are tuned and optimized to minimize false positives. Now let's move on and talk about phishing. So phishing is an attempt to acquire confidential information by masquerading to be a trustworthy person or organization. The damage potential of phishing is much higher. It can be both financial, loss of intellectual property, or damage to reputation. There's one especially dangerous variant of phishing, which is spear phishing, which is a targeted message that appears to come from a trusted person. And that trusted person can be your IT admin or maybe even your CEO. Let's look at an example of a phishing attack. So a phishing attack often appears like this. A very innocent-looking email message. In this case, it's directing you to get some files from Google Drive. Now, what's interesting is that often the link, the URL in the message, it is designed to appear like a legitimate URL from Google. You see, it says host.googledrive.com, which would make you believe it's a legitimate Google URL. But then it goes on, .service, .fish, something, and something. So it's just a random URL designed to look like something from Google. And I'm just using Google as an example. It could be your bank or any other organization that you trust. Now, if a user clicks that link, that will take you to a malicious clone of a Google sign-in page. And this can be designed to be a pixel-by-pixel copy of the real Google sign-in page. If the user unsuspectingly enters their credential, those credentials immediately go to the attackers. The attackers can then immediately use them to siphon off sensitive data, which can happen in seconds. And when after that happens, the damage is already done. So what does Google do to protect you against phishing? Before we go into the specific mechanisms, it's important to understand that as in many other cases, we use a defense-in-depth approach, meaning we have multiple layers of defense where we try to detect and reject any phishing attacks. And if they go and pass through undetected, we have additional layers of protection against those phishing attacks. So let's look at this is a list of some of the detection mechanisms that we have. So we have a detection mechanism that combines both rules written by security analysts with machine learning models. We have a real-time reputation system which is a database maintained in real time that covers domains, links, IP addresses. And the fact that we have, in Gmail, we have a user base of over 1 billion users, that gives us plenty of early signals that can help us maintain the database up to date in real time. And you, as enterprise customers, you get the benefit of that database, which uses the usage pattern we see from 1 billion users. All of these are signals used for the early detection. We also do anomaly detection on the various entities in an email message. So we look at things like what's the to from, what's the to field, the from field, and try to find any anomalous patterns, which will, again, give us a signal of this might be a phishing attack. We also look for brand impersonation. So brand impersonation would be, for example, if you have an email message that contains, let's say, the logo of Bank of America, but it's actually not from Bank of America. Again, that's a strong signal that this may be a phishing attack. So when we detect a phishing attack, we try to do it as early as possible and reject it, so it doesn't even get delivered. Now, what happens, and this sometimes does happen, if we detect a phishing attack after the message was already delivered. So when that happens, what we do, we go and reclassify messages that were already delivered. So if there's a new attack, we just found out about it, we're going to go and see if this attack is already present in messages that were delivered. And then we'll go and reclassify it. And it will have the warning that you see there, that big red warning, and the links in the message itself will be disabled. And by the way, this is a key difference in the kind of protection that you can get from a filtering gateway solution and what we at Google can give you. Because a filtering solution has just one chance to protect you, and that's when the email is delivered to your server. After that, if they discover something after that, they cannot go back and undeliver the message. We at Google, we can do it throughout the whole life cycle of an email message. Then we have another last line of detection, which is safe browsing. So safe browsing is triggered every time the user clicks a link, and then the link is going to be checked against a database of known phishing and malware URLs. And if it's found to be in the database, then instead of going to that web page, the user is going to be presented with this kind of warning, telling them that they're about to do something very risky, and they should not proceed. Safe browsing is available in Chrome, as well as Firefox and Safari. Now, so we have all these powerful detection mechanisms, but you may still ask, and this is a great question, well, what happens if something manages to go through undetected through all those detection mechanisms? Because it's an asymmetric warfare. The attacker only has to succeed once to cause significant damage to your organization. So we may be successful 99.9% of the times, and one attack can still be a huge damage to your organization. So we need some last line of defense to protect against the attack that did go through. And this is your line of defense, the security keys. So these are cryptographically secure second-factor authentication which are not vulnerable to phishing. They're based on industry standard FIDO UTF. They support both USB for use with laptops and desktops, as well as NFC, so they can be used with mobile devices. And they're secure. Even if an attacker gains access, gains the credential for an account, the attacker cannot log into that account because they need physical possession of the security keys. You actually have to physically touch the security key to gain access. These keys are simple to use, and as an organization, you can enforce the usage of the keys through the G Suite admin console. In Google, everybody uses security keys. You have to have security keys in order to log into any Google, internal Google corporate asset. And it's been working remarkably well for us at Google. Let's move on to the next threat, malware. So if you've been following the trends in malware for the last 10 or 15 years, you could see a big change from the first internet scale attacks that we saw in the early 2000s and the one that we see today. The malware of the early 2000s, they were designed mostly to cause some random damage, and they were designed primarily for fast propagation. So they just want to spread as fast as possible before the antivirus develops signatures and can detect and block them. The one we're seeing today are very different. They're much more sophisticated. They're financially motivated. So it's typically part of a crime ring, and it can be very profitable. They're targeted. They're stealth. And they use a number of countermeasures to avoid detection. And now I'm going to ask Nico to walk us through an example of such malware that demonstrates all these, the recent trends.
So we are going to go today over the case of Loki malware. So starting in February 2016, people started being targeted by that malware. So Loki is a ransomware. It uses encryption to prevent access to files until ransom is paid for. We estimate that 100 million people have been targeted by that particular malware. It appeared in multiple variants, and author released new version to counter defenses that are in place. So the targeting of victims has been also evolving over time. For instance, the victims of prior data breaches, for instance, OPM, have been particularly targeted by that malware when it came out. Ransomware is really a booming business with profits in the millions of dollars. So how does a Loki come up into your inbox? So it simply delivers as a simple email attachment. Appears here as a simple invoice in a Word document. So Loki is using social engineering to bypass default security settings and executing macros. So with this very advanced text, it's taking advantage of users. So the key lesson here is your protection is only as strong as your weakest link. And the weakest link is often the user. So even an attack with a high level of sophistication needs social engineering here. And now Loki is able to run the next stage of its attack based on scripting. So we're going to go into the detail of some of the detail of Loki. So Loki knows that modern malware scanners are using sandbox to monitor behavior of suspect files. So the sophisticated malware, like Loki, are using tricks to detect monitoring inside the sandbox. So here you can see an example of what Loki has been doing. They are just keeping track of time to detect emulation in a sandbox. So they start by checking the time, sleeping for some time. And sandbox typically do not really sleep. because people writing sandbox want to be efficient. They don't want to be like spinning idlessly. And then Loki is able to compute the time difference and figure out it was running in sandbox. And if it's running in sandbox, it will abort early and not have any malicious payload. Now, Loki is also targeting specific OSs. So it uses subtle difference in script engines to detect a specific target. If not on the appropriate target, it's going to remain dormant and avoid detection. So here you can see a snippet showing you how Loki only wants to use a Microsoft JScript interpreter, not JavaScript. It's just checking for specific syntax that only work in JScript and uses that to move along. So once the target has been identified, Loki moves the next stage and really attacks. It's going to download, install, and execute the malicious binary. Of course, this was like simplification. The actual payload is extremely obfuscated. I want to run like a lot of advanced services to disobfuscate all that content. So when the attack code is executed, unfortunately, all user documents get strongly encrypted. Loki is using actually secure encryption to ensure all the payload is locked down. As a ransomware, Loki is supported by a full e-commerce operation. So they host a decryptor website on Tor that's very resilient and untraceable. They also ask for ransom to be paid in Bitcoin to be untraceable. So now, how are we tackling malware in Gmail? So overall, we take a funnel approach, starting with blank rejection of common vectors. There's known high-risk format where we are actually just blanket blocking at the entrance level of Gmail. We also have a diversified approach that uses multiple file scanning technologies. We use internal scanners as well as external AV partners. We have intelligent attachment scanning. Start with signature-based, but we support deep scanning for risky attachment side. So risky attachment get deep scanning, which means the attachments are actually open inside a sandbox environment. And we monitor malicious behavior to detect something is a mark and consider that a piece of software malware without relying entirely on signature here. So we have a real-time continuous update on malicious content. We're also doing rescanning of content at download time. So even at the last moment when you click download, it's actually going to verify again whether the definition have been updated since then. Finally, we also do link scanning for malware detection. We are going over reviewing list of links that we know are malicious, and we prevent them to be downloaded. So once again, after the defenses could potentially fail, we still have safe browsing that constantly updates blacklist of suspicious sites. So safe browsing is taking care of leftover malware and phishing that potentially was not detected earlier.
Thanks, Nico. So we covered so far the 3 big threats related to email, which are spam, phishing, and malware. Now let's move on and talk about impersonation and interception. And before we talk about this, it's important to understand the root cause that these threats even exist. And the root cause is SMTP. So SMTP, as you may know, that's the protocol used to send email across the internet. It's one of the earliest internet protocol, and SMTP stands for Simple Mail Transport Protocol. And as the name implies, it is simple. It was designed for a safe and trusted environment. Threats were not taken into account, and therefore, SMTP, the original SMTP, has no security mechanisms whatsoever, which is why we have to deal with these threats today. So what are they? So impersonation is when an attacker sends email appearing to be from your domain or from one or some of your domain users. Interception is when an attacker gains access to email content in transit, typically by some man-in-the-middle attack, which is important because SMTP traffic typically travels over multiple hops between source and destination. And I'll let Nico walk us through some of the mechanisms that we have to deal with interception and impersonation.
So, first of all, for impersonation prevention, we rely on industry standards that add security on top of SMTP protocol. All those standards are taking advantage of DNS record with the sender domain to publish security settings associated with the domain. So we have SPF, which performing authentication by specifying what are the email servers to trust. DKIM, doing authentication using cryptographic signatures. And DMARC, which establishes a policy on how to deal with authentication failures. So first, SPF is fairly simple. It's registering the IP address of mail servers that are authorized to send mail from a domain. So here we have an example of the policy for google.com domain, which lists the known IPs from all our outbound gateways. So we have observed, though, several shortcomings with SPF. First, invalid records. People are putting invalid records in DNS. They don't realize that they don't necessarily parse correctly. And they cannot be parsed, therefore we are unable to make a determination on what the policy actually means. The record can also be whitelisting large IP ranges. And those IP ranges may fall outside the domain or allow undesirable hosts to send emails. Systems that are sharing public IP pools with different senders are also vulnerable to that type of issue. Then BGP hijacking has enabled attackers to quickly use priorly whitelisted IPs to send messages. And finally, DNS records are very important, and they can be hijacked, where the attacker will actually insert their own IP that authorized IPs to send emails. So DKIM came later and is offering cryptographic signing of sent emails using specific paired domain keys. So this example of a message, you can see the DKIM header, which is configured to target specific headers inside the message. That gives message ID, date, subject, from to. So those headers, as well as the body of the message, are in scope for hashing. So cryptographic hashing is done. That hash is added as part of the DKIM record, and that hash is signed using the specific domain key. Now, how is that signature verified? When the email is received, the DKIM header includes a selector on which key to fetch over in DNS. That key is fetched, and then it is used to verify the signature. So we get like cryptographic proof that the content of the message hasn't been tampered with. However, DKIM also has shortcomings. It provides like strong improvement over SPF, but standard is much more complex, requires cryptography, and several libraries that try to implement the standard actually had flaws in it. They did not verify everything, so it was actually abused. Weak keys, like 512-bit RSA key, have been used in DKIM, and attackers have been able to crack those keys and generate basically the private key associated with it, and are able to sign on behalf of the domain. So we don't trust weak keys anymore. Private key can also be stolen from compromised mail server. So misconfigure server that allows an attacker to breach in. The attacker can steal the DKIM key and can sign email, impersonating the domain. Finally, again, it relies on DNS. So hijacked DNS records have been used in the past to insert malicious DKIM keys. DMARC is offering a policy framework that defines the action to take upon failure of DKIM and SPF. Without it, the interpretation of DKIM and SPF is really left to the recipient mail server. So another feature of DMARC is also reporting. Reporting allows aggregate visibility of attempt to attack the domain. So this example for google.com record, sorry. You can see like the policy is set to reject messages failing DKIM and SPF. It also requires the server to send aggregate email with a list of failures. So the recipient domain, the sender domain impersonated, is able to figure out what's happening. So we have taken steps to surface authentication status to end users. The goal is really to raise user awareness of possible phishing attacks. We have a fairly clear visual difference set between the left side with an authenticated email that carries a logo for the domain, and the right side, which is unauthenticated with an appropriate symbol. Overall, we observe a really steady progress towards better email authentication. So non-authenticated email is now at around 1.8% in late 2016, down from 5.8% 2 years ago. Dual authentication with both SPF and DKIM is now at like 89.1%, up from 80.8% 2 years ago. So we are really getting toward a world where unauthenticated messages are really associated with something very malicious. Now I would like to go over another threat against email, that is interception. At this point, I'd like to give you a quick primer on 35-year-old SMTP protocol. So in standard SMTP, client basically connect to a server over TCP and assemble the email line by line. In traditional SMTP, all that is going over clear text. The server and client just communicate with each other. Now, if we look at the network perspective for this, the email message is transiting between Alice server and Bob server over internet. So an eavesdropper can trivially intercept any message. It doesn't have to be active. It's a just passive attacker just listening over the wire and be able to see the messages. SMTP encryption came as an afterthought in 1999 and was therefore added as opportunistic, which means it's best effort. It requires both client and server to support it. In this case, you can see the beginning of an SMTP transaction that supports STARTTLS. And the server advertises its ability to support the STARTTLS. So the client then establishes a full TLS connection. And inside that TLS connection that's encrypted, the actual content of the email can be transmitted securely. Back to our network perspective. The message is now transiting over a TLS encrypted channel. As a consequence, eavesdropper is unable to passively observe the message content. So in the last year, we've really taken to raise end-user awareness on the security of communication with various parties. So we introduced a broken lock UI, which basically simply showing to users whenever a received email was received over a clear text connection rather than a safe encrypted connection. With that user awareness, we've been able to drive adoption. Users started to ask senders why their email were not encrypted. Telling their banks, I'm receiving an email from my bank, why is it not encrypted? So because of this, at Gmail, we saw incoming email encryption rate go from the upper 50s to 82%. So surfacing encryption status to end user was enough to put pressure and drive encryption use. A very big win for the internet, because billions more messages are encrypted every day because of that backlog. The current status at Gmail is, of course, all messages between Gmail users are encrypted as always. But 82% of inbound emails from external sender are encrypted, and 88% of outbound email leaving Gmail service are encrypted. STARTTLS is not perfect, though. Email messages can travel multiple hops between sender and recipient. The STARTTLS is only hop-by-hop protection. As a consequence, eavesdropper can still intercept email if there's an unencrypted hop. So solution for this was to actually try to protect the message from the sender all the way to the recipient. So in January of this year, we added hosted SMIME support inside Gmail, available to G Suite enterprise customers. So SMIME is an industry standard for encrypting and signing messages with user-specific keys. SMIME is secure, but key management had traditionally made it very difficult to implement at scale in organizations. So with hosted SMIME support in Gmail, companies, domain administrator can upload user certificates and just simply use SMIME to sign and encrypt messages whenever possible. And keep eavesdropper out. So SMIME is not just providing encryption. It's also signing each message with a sender's key, protecting against impersonation and guaranteeing message integrity. Once rolled out, hosted SMIME requires no end-user involvement, which is a big change with the solution of the past. End users don't have to deal with the complexities of managing certificate and applying the encryption themselves. So now we're going to go over a different topic, which is client safety. Google is constantly investing in providing you with the greatest innovation. And Gmail clients are taking advantage of this to provide you with a safe experience. So modern email is based on HTML, enabling very rich content like beautiful image inside messages. However, it also introduces risk. So we are now going to dive into some of the inners of Gmail that are making this safe for users. So HTML in email messages is coming from third parties. So we do not have control over those third parties. Therefore, content can be potentially broken or contain unsafe elements. As a consequence, Gmail team is working on state-of-the-art sanitizer that fixes HTML and removes unsafe elements. So in this example of HTML content, I highlighted some of the content that needs to be fixed. Like an example is the margin, in that case, is invalid, potentially going negative, going outside of a window, and enabling clickjacking, overriding some element of the UI. The bold tag is not balanced, which can allow escaping outside of HTML content if the rest of the message is not balanced as well. The list should always be enclosed. The link URL should be fully qualified and go through a redirector, typically, to hide the referrer. And finally, of course, we have a script that should be removed to prevent cross-site scripting against your email. So after going through sanitization, the HTML document has been fixed and is safe to display within Gmail clients. Now, for images, starting in 2013, Gmail started proxying all external images. So we are doing this to protect you from senders who may try to use images to compromise the security of your computer or mobile device. So all images in Gmail are loaded through Google Proxy Service. They are delivered to clients over HTTPS only. They prevent leaking of IP address or cookies. And they also prevent malicious image format. So this, of course, is just a subset of the security capabilities we have been able to provide to you through our clients.
Thanks, Nico. So far we talked about different threats and attack vectors that come from outside the organization and they pose risk to internal assets. But think about the other way around. Email can also be used for data exfiltration. So you have, everybody has sensitive information inside the organization. Email can be used for that data to leave the organization and end up in the wrong hands. And that can be either negligent or malicious. So at Google, we provide DLP, data loss protections, to prevent such leakage. And I'm not going to go through all the different options that you have in setting DLP policy. There's a fairly rich set of rules and capabilities that you can define. This is just one example. So here you see defining a rule. The rule is going to be applied to all outbound messages, anything that leaves the organization and goes to somebody outside the organization. In this case, the rule will be applied to any message that contains a social security number. And so in the rules that we offer, there's a large number of predefined matches for sensitive data, such as social security number, as well as the ability to define your own custom matches for any sensitive data which is proprietary and unique to your organization. As part of the rule, you can also define what we should do when we have a match. So we can either modify the message, reject it, or quarantine it. So to summarize, we looked today, we gave you a picture of some of the protections that we build around your usage of email in Gmail and G Suite. And this is an area that is very important for us, and we're going to keep investing in that and improve those protections. But you have to keep in mind that it's for your domain, this is a shared responsibility. We're going to keep improving those protections, those mechanisms, but to really keep your domain safe, you have to take advantage of them. So before we end, I just want to walk through some of the things, some of the actions that we recommend that you take in order to keep your domain safe. So the first one is to use the security keys for authentication, for second factor authentication. And I cannot emphasize this enough. This is your best line of protections against phishing attack. If you use security keys and enforce that in your organization, your security posture when it comes to phishing is going to be an order of magnitude better. Next, so as Nico described earlier, SMTP is inherently not a safe protocol. So you should set up DKIM and SPF. We support both DKIM and SPF in Gmail and G Suite, but you have to set it up. So go to your admin console and make sure that it is set up and properly configured. And remember, so DKIM and SPF is used to authenticate your email. So it tells you basically tell the world, these are the server, they're allowed to send email on my behalf, and this is how I sign email messages to authenticate that these really came from me. Once you set up and configure DKIM and SPF, the next step, you should go ahead and set up a DMARC policy. DMARC policy is essentially, after you did the first step, saying, hey, world, this is how I send email. The next step is to tell the world, this is what you should do if you get email that appears to come from me, but it fails those authentication mechanisms. Like the signature doesn't match up, it's not one of the servers that I specified in my SPF settings. What should you do? So I can tell the world, if it appears that way, reject it or report to me, and this is the email address. So you can tell the rest of the world how to deal with something that comes from your domain and fails those security checks. It's a critical step to make sure that your domain doesn't become a source of phishing and spam if any machine by one of your users gets compromised. The next one is use SMIME. SMIME gives you the best level of security and encryption for email messages. That means every message is going to be both signed and encrypted with a user-specific key, and it's going to be encrypted through all the hops it goes between sending server and receiving server. Next, set up DLP rules. You have it, it's there, you just have to set it up. Every organization has and deals with some sensitive information. That can be social security number, bank routing numbers, license driving numbers, whatever it is. Make sure if you don't want that to leave the organization and end up in the wrong hands, do something about it. You can monitor it, you can reject it, you can set a policy that enforces it. And the last one is encourage user to use safe clients when they use Gmail. So as Nico showed you, we make a tremendous effort in making sure that we sanitize the content that we present to you in our email clients, whether that's the web client or Android or iOS. So take advantage of that. Your user's email usage is going to be much safer if they use these clients than if they use a third-party client. And last but not the least, as we've seen in the Locky example, the best security can be defeated by exploiting human weaknesses. So educate your users to use email responsibly, avoid risky behaviors, and pay attention to all the signals and the warnings that we provide to make sure that your organization stays safe.